discussed about structure of phloem, LS of phloem, where I told you about sieve tube, companion cell. Okay, that was in case of angiosperms. In case of gymnosperms, they have only albuminous cells and they have sieve cell. Albuminous cell and sieve cell in case of gymnosperms. But in case of angiosperms, you come across sieve tube, companion cell. Okay. Then there is phloem parenchyma and phloem fibers. See, phloem fibers are noticed during the secondary growth, not earlier to that. You find them there. So certain things that I wanted to say about examples for phloem fibers are jute, white the so the jute fibers. So then hemp and flax. These are all fibers which are obtained from phloem fibers. Fibers are the sclerenchyma I am talking about. They are in the form of fibers. They are dead tissue. You should know about that. Then there were certain points which I have not explained in the last class, like the protoxylem. Protoxylem are first form xylem elements. What are protoxylem? First form xylem elements. Metaxylem are formed later. Protoxylem have a small lacuna. See, protoxylem has a small lacuna. Lacuna means the space. Metaxylem is later formed elements, I told you, and they are having larger lacuna or space. Larger lacuna or space, cavity. Okay. So protoxylem are first formed elements. They are smaller in size. They have smaller space or lacuna. Metaxylem is later formed elements which are larger in size, and you find them to have larger space. Okay. Similarly, protoploem, the sieve tube is narrow in case of protoploem, whereas in case of metaploem they are broader. The sieve tube is broader. Narrow in case of protoploem, broader in case of metaploem. Okay. So they are similar. That's the reason I have written there. Now there are certain conditions called as, you call the stele. Stele is a region where the vascular bundles are formed. Stele generally it is covered by endodermis. Below the endodermis is the pericycle. Then you find the vascular tissue, pith or medulla. I will be discussing later there. Okay. So in case of XR condition, XR, stele is called as XR, EXARCH. Don't get confused with HEX. Okay, that is having 6 xylem elements, 6 phloem elements. This XR, what it indicates is, especially in case of root, what you notice is exo means external and endo means internal. What is external, what is internal? XR kalli the protoxylem is external. The metaxylem is towards the pith or internal. Protoxylem is external, that is towards the endodermis and pericycle. Metaxylem is towards the center. So we call this type of xylem arrangement, we call it as XR, EXARCH. In roots you notice that, monocot and dicot roots, you notice this XR condition, where protoxylem is towards the periphery, outside, and metaxylem is towards the center of the stele or pith. Okay. So the metaxylem or larger elements is found towards the center or the pith. So we call this arrangement as XR, EXARCH, XR. Then in case of endar, it is the inside out arrangement. Endar you can notice it in case of this vascular bundles of dicot stem leaf. What you notice is if this is the pith. In endar condition, the protoxylem is towards the pith and metaxylem is towards the periphery. This is endodermis. So protoxylem is towards the pith. Endo andre odage. ಏನು ಒಳಗಿದೆ? Protoxylem. The protoxylem is towards the pith or center of the stick. Metaxylem is towards the outside of the stick. This arrangement we call it as end-arc. End-arc arrangement is noticed in case of stem and leaf. End-arc arrangement is noticed in case of stem and leaf, both dicot and monocot. Okay. So whereas X-arc is noticed only in case of roots. It can be dicot root or monocot root. You can notice that. When you take a section and observe it under microscope, you can notice that. See, X-arc, what is the condition? X-arc means periphery. So what is at the periphery? Protoxylem is towards the periphery, towards the outside. Metaxylem is towards the pith. Whereas in case of the stem or leaf, protoxylem is towards the pith and metaxylem is towards the periphery. So we call it as end-arc condition. X-arc, end-arc. One more distinct feature of it, or distinguishing feature of X-arc and end-arc is X-arc is formed by centripetal development of xylem. End-arc is formed by centrifugal type of development of xylem. So based on development of xylem, if it is centripetal type of development, we call it as X-arc. If it is centrifugal type of development, we call it as end-arc. Okay. So in X-arc, what is external? Protoxylem is external towards the periphery. Metaxylem is towards the pith. Okay. What is end-arc? The protoxylem is towards the pith and the metaxylem is towards the periphery. So this is the conditions that you have to remember about. Okay. So that covers a major part. And primary xylem. Xylem is which is present before the secondary growth. We call it as primary xylem. Xylem which is formed after secondary growth. Increase in the girth of the stem, we call it as secondary growth. After secondary growth, the newly formed xylem, what do we call it as? Secondary xylem, or you also call it as wood. See, all these are wood. That implies they are secondary xylem. Okay. So the primary xylem is formed before secondary growth. Young dicot stem anta helthivi. Secondary xylem is formed after secondary growth. Increase in the girth of the stem. So this newly formed xylem, we call it as secondary xylem or wood. So please remember about it. The other name for secondary xylem is wood. If possible, we'll visit the Institute of Food Science also after the completion of chapter. Okay. So these are things that you have to remember about. Now the tissue system in plants, apart from what I discussed, tissues was different. Tissue system we are discussing about. We also have three types of tissue system, that is epidermal tissue system. Okay. Then we have the ground tissue system. So the first one was epidermal tissue system, ground tissue system, vascular tissue system, which we have to study in detail. So epidermal tissue system, epidermal is the outermost layer. Usually epidermis is single layer. They have different types of cells in the epidermis. Epidermal cells are there. It also has stomata. I'll be discussing about the stomata structure also. Then they have epidermal appendages. Appendages are the extensions. It can be either trichomes or it can be hairs, root hair. See, in root, you know that they have a root hair which is unicellular. Outermost, when we come to anatomy, I'll again discuss about it. The epidermal cell gives rise to an extension called as root hair, which is unicellular. Okay. In case of stem, the epidermal cell gives rise to a structure called as the trichome, which is multicellular. Okay, it is multicellular. Epidermis in case of stem or leaf gives rise to trichome, which is multicellular, whereas root hair is unicellular. So we will be discussing about that epidermal appendages also. Root hair absorbs water. Major part of absorption of water in plant takes place through root hairs. You have to remember about that. In the epidermal tissue system, we have the epidermal cells. Okay, epidermal cells are the outermost layer, and they'll be having within them the stomata and epidermal appendages, which we will discuss later on. Epidermis is usually single layer, but there are certain cases where it might be more than one layer. Okay. Epidermal cells, in case of stem and leaf, they have a thick waxy layer deposited on them. They have a thick waxy layer deposited on them, which we call it as cuticle. In case of epidermis, they'll have a thick layer of waxy layer deposited only in case of stem and leaf, which we call it as cuticle. Cuticle prevents the loss of water. Okay, so transpiration would be prevented by this presence of this waxy layer, cuticle. But in case of root, there is no cuticle. Why is there no cuticle in root? Because roots have to absorb water, isn't it? If they have this cuticle, water will not enter into the root cells. So that's the reason there is no cuticle in the epidermal layer of roots. So we call that as epiblemma. In textbooks, epidermis antane kodtare. If the epidermis doesn't have this cuticle layer, what do we call it as? Epiblemma. They are usually barrel-shaped cells that you notice. Okay. So epiblemma is found only in case of root, monocot and dicot root, where they do not have a deposition of this cuticle layer. What is cuticle? Waxy layer. Why should they be present? To avoid loss of water from the stem. But in roots they are not present because water should enter inside the root, isn't it? Root is the region where water absorption takes place, especially through root hairs. You have to remember about that. Then we have the next part, that is stomata. Stomata, in case of dicots, guard cells and tirata. These guard cells are going to be kidney shaped or bean shaped. See, in case of dicot stomata, the guard cells are kidney shaped or bean shaped, and they have richly filled with chloroplasts. See, leaf is the kitchen of the plant. Each and every cell of the leaf should have chloroplast to synthesize food through photosynthesis. Even the guard cells have chloroplast. That you have to remember about. And the inner wall of this guard cell is thick. Inner wall is thick. The outer layer of the guard cell is thin wall. They have nucleus. This is nucleus. The guard cells are, see this opening, what do we call it as? Stoma. The complete structure, we call it as stomatal complex. The complete structure, what do we call it as? Stomatal complex, which includes stoma, guard cells, subsidiary cells, epidermal cells. See, the guard cells are surrounded by cells which we call it as subsidiary cells. Outside the subsidiary cells, you have the epidermal cell. You will be taking a thin layer peel, epidermal peel. In case of leaf, you might have already done that. Stomata structure, have you studied it? Micro preparation. You take up epidermal peel, okay, and in that you find the stomata. So you should understand what you are taking. The transparent layer from that leaf is nothing but epidermal layer which has stomata. In case of dicot plants, the stomata has guard cells which are kidney shaped or bean shaped. Whereas in monocots it would be dumbbell shaped. Monocots, the guard cells are dumbbell shaped. Even they will be having chloroplast, nucleus. This is the stoma opening. Inner walls will be having a thick wall. Okay, inner thick wall, outer thin wall is noticed in guard cells. Okay, so both of them have subsidiary cells, epidermal cells. There is no difference there. Only what you notice is the shape of the guard cells. In case of dicot, it would be kidney shaped or bean shaped. In case of monocot, stomatal complex, it would be dumbbell shaped. Okay, remember about that. So this is the stomatal complex which has the guard cells. The guard cells outer wall is thin, inner wall is thick. The opening we call it as stoma. The guard cells are richly filled with chloroplast because they are found in leaf. And surrounding the guard cells, we call the cells as subsidiary cells. The subsidiary cells are surrounded by epidermal cells. Based on the type of subsidiary cell arrangement, there are different types of stomata, which I am not discussing here. Okay, which is not there for your PU syllabus. But for NEET, you have to remember that. Based on type of subsidiary cells, you have types of stomata, which we are not discussing at present. Okay. So this is about the stomata-stomatal complex. Stomata, why is it required? What is the function of stomata? Exchange of respiratory gases, then entry of water, exit of water can happen through stomata. Especially a lot of water is lost through the stomatal openings. 90% of water is lost through stomatal openings. We call it as the foliar transpiration or stomatal transpiration. When we come to transpiration topic, we'll again discuss about that. Okay, so this is also the epidermal tissue system, and you can notice this, which you'll also be studying under micropreparation, where you have to take an epidermal peel, stain it, and observe the stomata. Okay. Next is epidermal appendages, the extensions of the epidermal cells. We call it as epidermal appendages. I have already told you the root hair is unicellular. From epidermal cell, there is a unicellular extension called as root hair. Root hair absorbs water. Maximum water absorption from root takes place through root hairs. Whereas in case of stem, they have extensions called as trichomes. Trichomes are multicellular, they are not unicellular. Trichomes also avoid the transpiration. Presence of trichomes avoids transpiration. In some of them, they are trichomes are harder and they are also sharp. They prevent the grazing from animals. Trichomes, ಎಲೆಗಳ ಮೇಲೆ white hairs ಆ ಥರ ನೋಡಿರ್ತೀರಲ್ಲ, have you noticed that? Okay, in some of them they are harder and thicker trichomes. Trichomes' major function is it avoids transpiration of water when trichomes are present. Apart from that, they also prevent the browsing or grazing from animals, herbivores. Remember about that. So these are things that you have to know about epidermal tissue system. Now when we come to ground tissue, we have already discussed about parenchyma, collenchyma, sclerenchyma. See, parenchyma is found in the cortex. Now this is the screen. Covering the screen, you have epidermal layer, first layer. In between the epidermis and the endodermis lies the cortex. Cortex can be made up of parenchymatous cells. It can also have chlorenchyma. So in leaf, we don't call it as cortex. This zone we call it as cortex. In leaf, we don't call it as cortex. We call it as mesophyll, where they have chlorenchyma. What are the types of chlorenchyma? Two types are there. Palisade chlorenchyma, spongy chlorenchyma. Okay. So leaf and now cortex are the term used ಮಾಡಲ್ಲ. Instead, what do we use? We use the term mesophyll. Okay. So remember about that aspect of it. Primary phloem, secondary phloem definition ಗೊತ್ತಿದೆ ಅಲ್ಲ. Phloem which is present before secondary growth, we call it as primary phloem. Phloem which is formed after secondary growth, we call it as secondary phloem. Okay. So mesophyll will be having chlorenchymatous tissue. So the ground tissue we have already studied about that. ಈಗ ಪಿತ್ ಅಂತ ಇರುತ್ತೆ. This is the steel. The center ಅಲ್ಲಿ pith or medulla ಅಂತ ಇರುತ್ತೆ. This pith or medulla is also made up of parenchyma or in some of them sclerenchymatous cells. Okay, parenchyma you can notice. Mostly it is made up of pith or medulla is made up of parenchyma. So they are all the components of ground tissue. Parenchyma, collenchyma, sclerenchyma. We have already discussed. I am not going to discuss again. Mesophyll. Mesophyll is the cortical layer in leaf. We don't call it as cortex. We call it as mesophyll. They are made up of parenchyma richly filled with chloroplast. The chlorenchyma we call them as. Parenchyma is richly filled with chloroplast. We call it as chlorenchyma. They are of two types. What are they? Palisade chlorenchyma, spongy chlorenchyma. Palisade chlorenchyma, they are pillar-like or column-like cells which are tightly packed without intercellular spaces. Spongy chlorenchyma, they are spherical or ellipsoidal chlorenchyma with large intercellular spaces. You have to remember about that. Now we'll come for the last type of tissue system, plant tissue system, which we call it as vascular tissue system. We can also study it under the heading of vascular bundles. As the name indicates, vascular andre we are talking about xylem, phloem, cambium. What are we talking about? xylem, phloem and cavium, how they are distributed. That is what we will consider it as. See, vascular bundles or vascular tissue system, it is of two types. Radial vascular bundle, what do we call them as? Radial vascular bundle, conjoint vascular bundle. They are the two types. Radial vascular bundle, conjoint vascular bundle. Radial and radius. Xylem and phloem will be present separately. They are not present together. Conjoint ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, xylem and phloem ಜೊತೆಗೆ ಇರುತ್ತೆ. They are present together. Conjoint ಅಲ್ಲಿ. ಅದೇ radial vascular bundle ಅಲ್ಲಿ xylem is in one radii, phloem is in another radii. Again xylem is one radii, phloem is in another radii. ಅದೇ conjoint ಅಲ್ಲಿ ನೋಡಿ ಎರಡು ಜೊತೆಗೆ ಇರುತ್ತೆ. Xylem and phloem are together. See, radial vascular bundle you notice predominantly in roots. Dicot root, monocot root ಅಲ್ಲಿ ಮಾತ್ರ ನೀವು ನೋಡ್ತೀರಾ ಇದನ್ನ. Radial vascular bundle, the xylem patch is arranged in a separate radii, phloem patch is arranged in a separate radii. Since they are present separately in different radius, we call this type of sheath as radial vascular bundle. Radial vascular bundle is of tetra to hexad type. Okay, this is noticed in case of dicot root. Dicot root ಅಲ್ಲಿ ಇರುತ್ತೆ. Then polyarch you notice it in case of monocot root. See, I am not drawing the cellular details here. I am drawing a ground plan of it. In case of dicot root, you notice that they will be having 4 patches of xylem alternating with 4 patches of phloem. 4 xylem patches which are alternated by 4 patches of phloem. So xylem and phloem are present in separate radii and they are present 4 times. 4 ಸಲ ಇದ್ರೆ tetra. If xylem and phloem are present in 6 times, you find xylem patches alternating with 6 patches of phloem. We call it as hexa. Dicot root ಅಲ್ಲಿ 4 ಇರಬಹುದು ಅಥವಾ 6 ಇರಬಹುದು.